So in this video, we're going to talk about compiling source code when the number of like C files are too many. So consider the situation where it's like 10 C files, like there's too many source code. And that could be the number of programmer executes for legitimately slacking off my code's compiling. They will say, hey, get back to work. And then there's just idling away their time by answering compiling. Well, if it compiles, then well, the bot says, oh, carry on. He knows it. Okay. So if the number of source code is like really many source codes files, then well, it takes a long time. Sometimes it takes even an hour. So now consider the situation. You got some bug report and you want to compile like fix the bug, and then it seems like there's like a couple of C code you need to touch up on. So you just modify the source code like really quick, like maybe it was 10 minutes of worth of like fixing some bug. And then what? You have to check whether it works. You have to recompile it. And then it takes an hour. That's a huge amount of wasted time. Okay, so for that case, that's not really fine, right? So what do? So you basically compile each C code individually and then later merge them. Okay, so that what? Merging usually takes very short amount of time. And then what? You only need to recompile only 2 or 3 C code. And then that is taking short amount of time too. So like bug fixing and then recompiling will short amount of time, not 1 hour. Okay, so there's no room for what? Slacking off in a sense, you work hard. Okay, so how do we do that? So let me share the terminal. So the way to do that is this. Let's say you have 2 files, right, as before. So you have GCC. You use GCC to compile, but you give -C option. -C means compile only. Okay, so you only just compile 1 file. So there's 2 files. So let's say main.c. Okay, if you do that, then you will see main.o file is created. Okay, so what does that mean? So in picture, you have main.c, and then you use GCC -C option, and then you created main.o file. So the main.o file is also is machineable, is really machine code. Object code is usually called. And then likewise, there's another helper.c C code, helper.c source code. And then you compile only that thing, and then you create helper.c. Okay, how do you do that? GCC -C helper.c. Okay, so now we have 2 files, main.o and then helper.o. Sorry, this is helper.o. And then you have to merge these object files into executable. So if you do GCC, and then you give what? All the object files, main.c and main.o and the helper.o. If you do that, a.out is created. Okay, it's already created. So I'll just use -o option as before. So -o, then what? Let's say new file, new x. And then you see new x is created. New x is what? Executable file. So this is compile each, and then you do link. Link is basically merging all the object code. So linking is necessary because, like, you know, the main.c file uses all the functions, and you have to, in some sense, find out the actual location for the function and then call it. So all this like linking procedure must taking place, and that's link. Okay, and then you got what? New x, final executable. Okay, so that's it. So this way, you can actually compile many source code efficiently, recompile. Okay.